Okay. This is problem 46 from chapter 2. 46. It's not a suggested problem, but it's a level 3 problem, so I thought it might be instructive to look at this. Here we have a runner that hopes to complete a 10K run in less than 30 minutes. After running at constant speed for exactly 27 minutes, there are still 1100 meters to go. The runner must then accelerate at 0.20 meters per second square for how many seconds in order to achieve the desired time? Okay, so we have a runner. Let's draw something simple. The runner is here. This is where we are after running 27 minutes. And we have still 1100 meters to go. And we want to do this in some delta t of 180 seconds. This is what we're going to do. And to do that, we can't actually accomplish this with our current speed. We'll accelerate for a while. So there's going to be some acceleration. And then we'll continue with the speed that we gained till the end. So there's going to be a constant acceleration motion phase, and there's going to be a constant velocity motion phase. Now we can do this in a number of ways. So we can do this, for example, similar to 58. We can say that this is my point 0, this is point 1, this is point 2. And I can say that this is x0, x1, and t1, and t2, t2, and so on and so forth. But we can also do this in a different way, with a different formalism. And I'm going to choose that one. I'll just divide this into two phases. So my phase 1 and my phase 2. And in these two phases, I'm going to have some delta t, I'm going to have some delta x. And I'm going to have an acceleration in the first one and no acceleration in the second one. So what I want is my delta x1. This is my displacement in the first phase, plus delta x2 is 1100 meters. And delta t1 plus delta t2 is 180 seconds. All right, now, and I want to have some acceleration. So let's have something with acceleration. That will be the displacement for the first part. Delta x1 is going to be v1 delta t1 plus 1/2 a delta t1 squared. And so that acceleration is given, that a is 0.2 meters per second squared. v1 is what I have at the beginning of this. So I start here at v1, and this I can deduce from the fact that I actually spent 27 minutes for the beginning of the race. So beginning of the race is 10,000 minus 1100, that's 8900 meters for 27 minutes. So v1 is going to be 8900 divided by 27 times 60, whatever this is. It's not very important, but v1 is something we know. Okay? And then for delta x2, we actually have v2 delta t2. And that's it. There's no acceleration here. It's just going to move with constant velocity motion. v2 we can connect to acceleration and v1 as well. So v2 is v1 plus our acceleration times delta t1. So this is what happens during the first phase. I started with some v1. I spent some time delta t1 with some acceleration that changes my velocity to v2. So how many equations and how many unknowns? Now I have 1, 2, 3, 4. This is a known. 3, but I have this equation. 5. 5 equations. And 1, 2, 3, 4. 5 equations for 5 unknowns. I can solve this in principle. Now, I'm not going to solve it completely. It's just that this can be done. Now, it can be done by a computer even, if you know how to give these, how to feed these equations to computers. 5 equations, x1, x2, 22. Yeah, that's correct. So you could say that v1 is also unknown, but you have it over here. I dropped it. Now, one way to approach this would be to put this and put this over here. Then you take this one and add up to this one, you get this. That is going to involve both T1 and T2. That equation, that resulting equation, is going to involve T1 and T2. And you can use this one to solve for T2 in terms of T1. And substitute into that one. It's going to be a mess. It's going to be probably a quadratic equation. It's going to definitely be a quadratic equation. I can't imagine this is going to be linear. But you can solve for it. And you get a quadratic equation and solve it. It's not that complicated. Not that complicated. So my strategy, the first thing when I look at this will be take this, substitute in here. Take this, add to this one, which will be equal to 1100. That big equation is going to have both T1, delta T1 and delta T2, and then solve for delta T2 here, substitute into that big equation, you get a quadratic for delta T1, solve for it. And then, you're going to, this will be your answer. They're asking for how many seconds in order, they are going to accelerate for how many seconds in order to achieve the desired time, so that will be your delta T1. I'm not going to do it because it's going to be a mess, but it can be solved this way, and probably the solution can be found in the solution manual. I don't know if this is this solution, but I'm not going to go into the details of it any further.